Log base 7 of 3x equals 3. 2 days ago, we went over this in 7-3. Everyone remembers this, correct? What you need to understand is that this is logarithmic form. Please copy this down. If this is logarithmic form, just write this down. I'll just call it log form for short. If this is log form, what is exponential form? If this is log form, how could we display exponential form? Exponential form would be base raised to the exponent. So please copy this down. It would be base raised to the exponent equals the answer. Log form is log base answer equals exponent. Exponential form is base raised to the exponent equals answer. And let me show you what I mean. So say the base is 2 raised to the third power. That equals the answer, which is 8. 2 raised to the third power equals 8. Base to the exponent equals answer. Log form would be log base 2 of 8 equals 3. So log form, log base 2 of 8 equals 3. Exponential form, 2 to the third power equals 8. Do you see how these two forms are related? All right. Hopefully you wrote that down. Hopefully the colors could help you solidify what's going on the board. I'm going to erase this now. So in order to solve a logarithmic equation, we rewrite it in exponential form, and now we could solve it.
So they're always going to be written in log form first?
Yeah, if it's a logarithmic equation, it's going to be in log form first. We have to rewrite it in exponential form so we could solve it. If it's an exponential equation, it's going to be written in exponential form, but the exponent's going to be a variable, and then we could bring it down to the base level, write log on both sides, and use logs to solve it that way. 7 to the third power. 7 to the third power. 27 calculator, 7 to the third power. Do you have me on? 343. 343 equals 3x. And divide both sides by 3. And x is equal to what? 114.3. Are there any other decimals, or did it just stop after that? Repeating? All right. 114.3 repeating is the value for x. That was our first examples. Any questions?
How did you get 7 to the third again? You just switched it, right?
Yeah, we went from log form to exponential form. So 7 to the third equals 3x. Next example. Please copy this into, yes, Brianna. Yeah. This is a logarithmic equation because our variable, the x, is connected to the word log. Logarithmic equation. In order to solve it, we have to rewrite it in exponential form first. Just a reminder, exponential form is base raised to the exponent equals answer. Can I have a volunteer tell me what exponential form would be? First things first, you need to identify the base. Let's start off basic, simple. So what's the base? It's 10. How do we know it's 10? We don't see it. If you don't see a base, you know it's 10. So if you don't see anything, exactly. So in the first example, you saw that it was 7. So you know that it's 7. But if you don't see anything, like in this case, then it's automatically 10. Yusef. So another way you could think about it when you go from logarithmic form to exponential form, you start at the base. So you always start at the base, then you go around the equal sign, like that. So this is going to be 10 raised to the second power, go back around, equals 3x plus 1. So you can think of it that way. Same thing here. You can start at the base, 7, go around, 7 raised to the third, come back around, equals 3x. 10, go around, raised to the second, come back around, equals 3x plus 1. So it's always going to go in this circular motion to go from logarithmic form to exponential form. Now that we're in exponential form, this is a basic equation. 10 squared is 100. 100 equals 3x plus 1. Subtract 1 from both sides. 99 equals 3x. Divide both sides by 3. X equals 33 is our answer. X equals 33. Next example. Any questions on this one? All right. So again, this is a logarithmic equation because the word log is there, logarithmic equation. We want to rewrite it in exponential form. Exponential form, the word log will not be there in exponential form. First thing we need to do is isolate the log. How can we isolate the log? Any ideas? Anthony? Divide both sides by 2. Now we have log of x. Log x of x equals negative 1/2. Now that the log is isolated, this is logarithmic form, we have to rewrite it in exponential form before we could solve it. And again, exponential form is base raised to the exponent equals the answer. Somebody knew. What is the base here? What is going to be exponential form? Juliet.
The base will be 10.
The base is 10. All right, so 10.
And the exponent will be
Negative 1/2 is the exponent. So 10 raised to the negative 1/2. Continue, please.
And the answer will be x.
And the answer is x. Everyone is clear on why the base is 10, right? When you don't see a base, the base is always 10. All right. We're done. There's nothing left to do here. Just plug this into your calculator and that's your answer for x. So what is x? 10 raised to the negative 1/2 equals x. Ian. 0.316 equals x. Good? Next example. So one thing I want you all to see in this example, what makes a logarithmic equation is that the variable is connected to a log. The variable is connected to a log. Just like an exponential equation, the variable is an exponent. You follow? In a logarithmic equation, the variable is connected to a log. So this one here, Negative log of 3, that's not logarithmic equation. We could just put this in our calculator. It's going to be a decimal. We'll just have to round. So negative log of 3, that's a number. That's a number you could put in your calculator and figure out what that number is. So the first thing we're going to do, because you can see we have more than one log here. We cannot go to exponential form with more than one log. We could only have one log in order to go back to exponential form. We could get rid of this log by putting this in our calculator and figuring out what that number is. So can you please put log of 3, not negative log of 3, just log of 3 in your calculator, and you're going to get a decimal. The more digits you use, the closer your answer is going to be. So take maybe 5 or 6 decimal places so we can get closer to the correct answer.
47712.
Hold on, 0.4?
Yeah.
So 0.47712?
Yeah.
All right. So the first thing we want to do, before we could go to exponential form, we need to have one log, one and only one log in our equation before we could go to exponential form. So we have log of x minus 0.47712 equals 8. Does that first step make sense? If you have more than one log, use the log that doesn't have the variable and figure out what that value is and use that numerical value so that you only have one log in your equation. Now, what do you think we're going to do? Can we go to exponential form now? Valentina? Exactly. We need to isolate this log first before we could go to exponential form. Good job, Valentina. So we'll add 0.47712 to both sides. Log of x equals 8.47712. Now we have one log and the log is isolated. Now we can go to exponential form. And to remind you, exponential form is base raised to the exponent equals the answer. All right, put this over here somewhere. All right. Ian, what is exponential form going to be?
Maybe 10.
10?
8.4771.
8.47712 equals x. Thank you. Nice job. There's nothing left to do but throw that into our calculator. That's going to be our value for x. It's going to be a big number. Should be 3.00. Is it 29? Yeah.
29
All right, so we'll just round that to 3 million or 30 million. What is it, 29 million or 2 million?
29 million.
So let's round that to 30 million. Because when we round, our answer is not going to be exact because we rounded this one over here. When we first started, we rounded that. If we included even more digits, we'd get closer to the accurate answer. Juliet?
I didn't round the exponent and I got 300 million.2.
Yeah? Oh, you did not round?
Yeah.
Exactly, and that's the correct answer right there. When you don't round, you'll get the exact answer. But if you round, you'll get an approximation. But you could just, if you know how to use your calculator, you could just add the answer from the previous line so that you'll get the, does everyone know how to do that? All right. So you'll get the exact answer if you don't round. But if you're rounding, you'll have an approximation. All right. Last one we'll do together. Let's hear your thoughts. You have all the tools to handle this logarithmic equation at your disposal. There's nothing I could tell you that you do not already know. Anthony? You could, it'd be sloppy though if you did that first, but you could to answer your question. Yeah. Yeah. So let's turn log 4 into a number. 2 log x plus whatever log 4 is equals 2. So what is the value? What is the value of log 4? Angelina? 602.
206.
Double 2 or just 1 2?
1 2.
206. All right. And again, this is an approximation. If you know how to use your calculator, you don't have to round at all, and you'll get the exact answer. If you do not use your calculator and you want a closer approximation, use more values. The more decimal places you use, the closer to the exact answer you'll get. All right, that's the first step. What shall we do next? Ian? Yes, so we'll subtract this from both sides. Now we have 2 log x equals what? What does that equal? 1.3, 97, 940. All right. And again, I'm using these rounding numbers because I'm showing you work on the board, but if you're on your calculator, you could just use that exact answer by copying that answer into the new line on your calculator. What's next? I cannot tell you something you do not already know, not Spencer. Gabby? Divide both sides by 2, exactly. Now we have log of x equals, someone give me that value.
0.6.
Hold on. Log of x equals what? 0.6?
Yeah. 98970.
93.
989.
989.
No, no, no.
Okay, go back.
Yes.
0.6.
Yeah.
9.
98970.
Okay. Now, this is the new stuff we learned today. What do we do now? Marie G.
Don't you have to make it into that form?
Exactly, exponential form.
It's 10 plus to like that.
Okay. X equals 5.